we're continuing to finish up on chapter 1.4b, so further notes on continuity. Okay, so first, continuity on a closed interval. If a function is continuous on an open interval between a and b, so here's our graph between a and b, and the limit as x approaches a from the right side of a is equal to the ordered pair of f of a, and the limit as x approaches b from the left side of b is equal to f of b, then our function is continuous on the closed interval a to b. Okay, so if we know that these conditions are true, then we know that the graph has to be connected through those 2 points, or connected to those points from the graph. Okay, intermediate value theorem, or IVT. Let me read through this first, and then we can look at some examples. So if our function is continuous on a closed interval between a and b, that means we can the endpoints are defined and there are no breaks between those two endpoints, and k is any number between f of a and f of b, then there is at least one number c in the interval a and b such that f of c is equal to k. So in other words, what this is saying is if a function is continuous, so in this case we see the function is continuous between a and b, then it has to hit all the y values between the endpoints at least once. So in this case, our endpoints are at y value of 5 and a y value of 1. So we know that because the graph is connected, that all the y values between 1 and 5 has to be at least reached by the graph at least once, right? Now, it's possible that the graph may be able to may have values that are above 5 and below 1, but if we only know the information about the endpoints and we know that the graph is continuous, then the most that we can say is we can guarantee, based off of the limited knowledge, just those given information, it's just going to be between those two endpoints. Okay, so for instance, let me give another visual example. Let's say I had a graph continuous between a and b, but now my endpoints are at y value of 1 and y value of 3. Now suppose that we can't see the graph, but we just know that the endpoints have y value of 1 and y value of 3, and we know the graph is continuous between those two endpoints. Then we can guarantee that any y value between 1 and 3 will have to be reached by the graph at least once. And we see that's true in this case. However, those may not be the highest and lowest points of the graph. In this case, the graph reaches to -1 and it goes up to 6. But just based off of our limited knowledge, we can guarantee just the y values between the endpoints. Okay, so let's look at example 1. Use intermediate value theorem to show that there is a 0, or y value of 0, on the interval between 0 and 1 for our function x cubed plus 2x minus 1. Okay, so first off, IVT requires continuity. So we have our function x cubed plus 2x minus 1. Now this is a polynomial, so if it's a polynomial function, then the graph is going to be continuous throughout. So we can already state that the function is continuous. Now we do need to test the endpoints. So our endpoints are at 0 and 1, so I'm going to plug 0 and 1 into the function to see what the y values are. So f of 0 gives me 0 plus 0 minus 1, which is -1. F of 1 gives me 1 plus 2 minus 1, which is 2. So my endpoints are at y value of -1 and a y value of 2. And we know the graph is continuous. So that means the graph has to hit every y value between -1 and 2 at least once somewhere on the graph. Now it's possible that the graph may go up below -1 and above +2, but just based off of this information, right, that function is continuous and these are the endpoints, we can only make statements about what's between these two endpoints. So we can say that the graph is going to hit 0 because 0 is between -1 and 2. So we know just based off of this knowledge, we can conclude that that there must be at least one y value of 0 on the graph. Okay, next example. Verify that intermediate value theorem applies for our function on the intervals between 5/2 and 4, and we're trying to prove or show that the graph is going to reach the y value of 6 at least once. Okay, first off, if we look at this graph, we know that it's not going to be, there is going to be a break in the graph. It's not a polynomial like the last example, and the break is going to be at 1. Okay, so we can say that the function is continuous on an interval between 2.5 and 4 because 1 is outside of the interval. So the continuity issue is not going to affect our problem here. It's not going to affect our interval. So we can continue with the theorem because we know the function is continuous on this interval. The only break that we see is at the vertical asymptote, which occurs outside the interval. So we're okay there. Okay. So if we want to prove just by the endpoints that the graph is going to reach a y value of 6, then these two endpoints have to provide y values above and below 6. Okay, because we're only going to be verifying this by limited knowledge of continuity and the y value of the endpoints. Okay, so just based off of the limited scope of IVT, the only way that IVT is going to pass is if it's continuous and if the endpoints sit above and below our target y value. So we just have to plug these in and see what the y values are. So if I plug 2.5 into this function here, I'm going to get 35 over 6, which is about 5.8. If I plug 4 into this function, I'm going to get 20 over 3, which is 6.7. Now 5.8 and 6.7, this is enough information for us to guarantee that the graph will hit a y value of 6 because we see the endpoints sit above and below this target y value. Okay, so therefore, through IVT, there must be at least an f of c equals 6 between 5/2 and 4. Now this problem is asking a little bit more because now we have to find the location, the x value, where this y value is crossing 6. Okay, so the way that we do that, we're just going to be setting our function equal to 6 and figure out the x value where that occurs. So here we can just use cross product to solve for x. Cross product and bring everything over to one side. We can factor. So 2 and 3 are where the graph is going to hit the y value of 6. However, we have to remove 2 because x equals 2 is outside the endpoints. We're only asking about the graph reaching 6 between the endpoints of 2.5 and 4. And we see 2 is outside the interval 2.5 to 4. So only 3 will be our solution. So C is equal to 3.